Software development can be a lot of fun, and one of the best ways to demonstrate that is by making your own video game. In the next 60 minutes we'll be creating a nice little 2D retro shoot 'em up, and we're going to do so in HTML5, meaning that we can start off with a little more than a standard web browser and a basic text editor. This here is Google Chrome. Everything we create will be instantly playable here. Right now all there is a 404. That is because my working folder is still completely blank. So we'll start up a text editor, and I'm using Vim, but don't worry. Any text editor will do, so use whatever suits you best. And as for the name of the game, I came up with YARS, Y-A-R-S. It's an acronym. I'll leave you thinking for a moment what it means. And in the meantime, I'll be creating 3 separate files: markup, styling, and JavaScript. And as for the markup file, that's full of boilerplate, so I'll fast forward through that. The really interesting part is the canvas. The canvas has dimensions. I'll settle for 640 by 640 pixels for now. As for the name of the game, YARS, that stands for yet another retro shoot 'em up. Enough for the markup file. On to the styling. There's not a lot of styling we need to do, because all we have is a canvas. Our retro shooter will be set in space, and space is kind of black, so I'll settle for a black background for now. We'll improve that later on. On to the third file, JavaScript file, which is where we do the actual drawing on the canvas. So we need a reference to the canvas, and from that reference we need a drawing context. A video game basically is just an interactive animation, and an animation is made up of frames, and ideally it should be running at 60 frames per second. Now for that we have a neat little function in all major web browsers called request animation frame. If we pass the name of the encapsulating function to that, then the rest of this code will automatically be executed at 60 frames per second where possible. And every frame will start by clearing the entire canvas. We'll also increase the frame count to keep track of the animation. You can also use a timer for that. Most of the time I actually prefer a timer, but in this case for simplicity I'll stick to a frame counter. So let's see what that results in. We have a black rectangle, no errors in the JavaScript console. Great, we need to keep an eye on that one too. Not a lot to see here, so let's start with something simple. Let's put some text on the canvas. For that we'll set some properties on the drawing context first: the font size, color. Now we can draw for every frame some text using fill text. We still need a string to paint, so let's add a variable with some zeros in there. And we need an x coordinate. We'll calculate that based on the width of the text. And a y coordinate, we'll have that one fixed. Let's see if that works. And there's the text. We could turn that into a score counter, of course. For that we'll simply add a variable named score. And we'll also add a click event handler on the canvas, so that every time we click the canvas, the score will be automatically increased by, let's say, 25. Okay, we'll still stick to the zeros string to have some zero padding in there to give it a bit of a retro feel. Click, click, click. That works. It looks a bit dull. I prefer those running score counters. So we'll add another variable for the score counter. Now for every frame we'll increase the score counter by 1 if the score counter is less than the actual score. Refresh, click, 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 click. Look, Ma, no hands. We made ourselves some kind of cookie clicker. Okay, that's not a lot. We need some graphics. I could pull some stock images from the internet, but where's the fun in that? We'll draw some ourselves. So I'll start up the GIMP, create a new image with a transparent background. I'll zoom in a bit so that you can clearly see what I'm doing. First thing I'm going to create is a ship for us to fly in. I'll snap to grid because I'm using the mouse to draw. I'll take the lasso and start drawing from the top center. Draw a diagonal line somewhere to here. Make a really basic shape because I'm not much of a painter. We have a bit of a triangle. I'll fill it in with some Star Wars gray. Well, actually I made it a bit more bluish to give it a bit of a metallic feel. And there we have our triangle. We can duplicate that layer, flip the layer horizontally, merge the layers together, and we have a bit of a kite shape, which is not much of a ship, so I'm going to distort it with whirl and pinch. I don't need the whirl because this is going to be a ship and not a cup of coffee. And the radius, I'll maximize that. And now we can slowly pinch it down and you'll see that the body becomes contracted until it becomes a bit of a ship shape. There. Okay. And we'll make a selection out of that. Add a transparent layer on top of it because it feels a bit flat. So I'm going to put a bit of a gradient on top of it. So I'm going to use one of the flare gradients, this one. And I'll put some on the wing. And I'm going to put some on the body. There we go. Now we can duplicate that layer, flip that layer horizontally, and now invert the colors of the top layer. And we have some more depth. Merge the layers together. Duplicate that layer. I'll remove the bottom layer so that you can clearly see what I'm doing. I'll take a rectangular selection. Delete everything outside the selection. I'll scale this one to a percentage of 25. There we go. Let's move that one to the side a bit. We'll restore the original layer, put the original layer on top. And as for the small layer, I'll duplicate that until I have 4 of them. Now I can use them to put some bombs under my wings. Because mean looking ships always have bombs on their wings, right? There we go. Nice. Okay. The ship is still a bit too big. I'll scale it down to a percentage of 30. I'll auto crop it. Now we can save it. We'll call it ship. We also need to export it to PNG because that's the format that my web browser understands. Now we can go back to the markup file and add an image tag with an ID ship, and the source is the file that we just created. Now I'm putting that on the document not because I want it to be shown on the document, but because then it automatically gets loaded by the web browser. I'm going to style it away here because I only want to show it when it's drawn by the JavaScript code. And I'll introduce a global variable for my ship. And now we can actually use the drawing context to draw the ship. We need some coordinates. Let me declare some here. mx, well, I'll start with fixed values somewhere at the center bottom. Refresh. There it is. Now we need some control over the ship. So I'll add another event handler. This time it will be a mouse move event handler, which will calculate mx and my based on the mouse coordinates relative to the canvas coordinates. Same for y. Refresh. And that works. Now the problem with images is that they take some time to load, especially on a slow internet connection, and you don't want your game or animation to start until all the images have actually loaded. Now I could use the load event of the document, but that's not going to help because I can show you that gets fired before all the images have loaded. So what I'm going to do instead is I'm going to monitor the onload event of every individual image. Now for that I either need a list of images or a counter. For simplicity, I'll simply use a counter and I'll call it toLoad, which is the number of images to load. Initially it's 1, and the main function will not be fired until it hits 0. And I need the entire list of images. And I'm going to loop through them. And for every individual image, I'll increase the toLoad counter. And I'll also add an onload event handler. And in that onload event handler, I'll decrease toLoad again. And now what you see is that we have 2 individual places where main can be called. If the images are slow, then the last one to load will get the honor of firing main from its load event handler. If all of them load fast, then it will probably be executed from the bottom here. Okay, let's see if that works. And it doesn't work. Just blackness. Even the text is gone. So what went wrong? Well, the problem is by now the image has already been cached by the browser, which means that the load event is fired before I even got a chance to add the onload event handler. So what I'm gonna do about that is I'll go back to the markup and I'll remove the source attribute here, because an image without a source cannot be loaded by the browser. And instead I'll fill that in here. And the source will simply be the ID followed by the extension PNG. Now that's better. Now one more thing that bothers me about this is that the mouse cursor doesn't clunk to the center of the sprite, but to the top left. Now that's easy to fix, of course, because all we need to do is before we draw the image, we first get the width and height of the ship. And then we subtract half of those from the coordinates. I'll also add some rounding so that it will always be integer coordinates to prevent problems later on with collision detect. That works. Now doing this will become a bit tedious for every individual sprite because there will be more. What I would really like is for the ship itself to have some kind of draw method where I can just pass in the coordinates and it will do the calculation based on its width and height itself. Now, that's not too hard to do. I'll remove the original 3 lines and I'll move them to the bottom before the game starts and everything is loaded. In the onload event handler, I'll calculate the width and height. I've got to replace ship by this so that it actually works for every sprite. And now we can actually define ourselves a draw function, which takes 2 parameters. We have to replace mx and my by the parameters. Let's see if that works. That works too. Okay, great. Yeah, we need some more sprites. A bullet to begin with, because we need to shoot. So I'm going to create a new image. And I'm going to zoom in again. I'll snap to grid. This time I'll also show you the grid. I need a brush. And the color doesn't really matter. I'll take black for now. And we're going to draw a very simple line. There. That's going to be our bullet. I'm going to put a filter on it, which is neon. Okay. We can remove the background from there and we'll auto crop it. And we can save it and call it bullet. We'll export it to PNG and we'll go back to the markup file where we already had the ship defined, and we'll make a similar image object bullet. Now we need to draw it over here. Since the positioning of the bullet is less trivial than it was for the ship, I'm going to introduce some objects. So it's going to be more object oriented. First of all, we need some kind of base object, which is the sprite. For now, it only has a draw method with no parameters because it's going to use its own properties. First of all, an image property, which already should have a draw method, which we defined just now, and X and Y properties. Now that we have this base instance, we can start creating some kind of classes. First of all, for the ship, and the ship needs an image, and that image was already defined down here. So I'm going to delete that, put that one up here, and we'll replace this by new ship. Okay, let me get these variables out of the way. Prefer having those on top. Okay. Next, we also need a move function. And that one is fairly trivial. It calculates X and Y based on the mouse coordinates. Finally, we have the prototype, which is the base object sprite. Okay. Now, all we need to do to get this working is remove the parameters from this call to draw and add a call to move. So we call move to position, sprite, and then draw. And that works. Now we can do the same for the bullet. But again, if we have a lot of sprites, that also becomes tedious. So I'm going to go one step further and introduce groups of sprites, and I'll call them families. And the family function will accept an array of sprites, and then it will return a function that will accept as a parameter some kind of function name or method name that it will then apply to every sprite that's in that array that we passed it. So we'll get every sprite, get that method, call the method, and now we can introduce our first family, which is the family of the good guys. And its members are first of all the ship, and secondly a bullet. Now we still need to define that bullet, of course. I'll actually make 4 bullets out of it. This is really retro. Instead of instantiating objects dynamically, we'll just have a fixed supply of them. Let's just copy paste everything from the ship. That goes a lot faster. There we have the bullet. Now the movement is less trivial, like I already said. It's gonna be a movement upward. So first of all, we need to check if the bullet hasn't already flown out of the screen. If it hasn't, then there will be some movement, and it will be a movement up, so we'll simply decrease the Y coordinate by, let's say, 20, so that it doesn't become too slow. And once it has left the screen, then it can be fired again. And we'll check a variable called fired for that, And firing the bullet simply means that I'll put the X and Y coordinates equal to those of the ship, or rather to the nose of the ship, which is slightly higher. Now we need to introduce that fired variable, of course. And let's say that if we click the canvas, then fired becomes 1. Okay. Now one more thing we need to do is we have to replace those two method calls, move and draw, by calls to the good guys. So we'll tell the good guys move, and then we'll tell the good guys draw. Let's see if that works. Oh, there's a bullet up here. That means that we didn't properly initialize the Y coordinate. So we'll put that way off the screen so that it becomes immediately prone to being fired. And that's a lot better. Okay, now that we have good guys, we also need bad guys. So we're gonna introduce more sprites. I'll start creating some straightforward invaders. I actually need 3 of them. And for that, again, we'll snap to grid. Fortunately, I need to set that for every sprite individually. Snap to grid. And this time I'm not snapping to grid because I need a steady hand, but because you can use it to make it a bit more like pixel art. I'm just gonna draw some random stuff. I'm gonna duplicate that layer, flip the layer horizontally, merge the layers together. Do that for the second sprite as well. Just do whatever you feel like. So it doesn't really matter what's in there. Duplicate the layer, flip the layer, merge them together. And that's the nice thing about doing this. Every time I do it, it turns out with totally different sprites. Duplicate, flip, merge. Okay. Now we can finally put the neon filter on that. This time we're going to change the colors. For this one, let's make it fully saturated red. Oops. There we go. Can remove the background. And the third one, we'll make it fully saturated green. Great. Remove the background. And the last one, you probably guessed it. Go for blue. It's easy enough. Yeah. Away with the background. Okay, they're a bit too big, so I'm gonna scale them to 50%. This one too. And the third one. Now we can finally auto crop them. Crop, crop. And we can save them. The first one will be Invader 1. Export to PNG. And second one, Invader 2. Export. And number 3. And export to PNG. That's it. Let's go back to the markup. 1, invader 2 and invader 3. Now we need, of course, a sprite definition. I'll copy paste the ship. We'll call it invader. And this time the image name, the image ID will be dependent on a parameter. And we'll have some really simple movement. I'll actually first start with a little function to help us normalize the coordinates. I'll call it move2. I'll give it 2 parameters, x and y, so that I can use the canvas width. And I'll use half to make sure that all movement will be centered, will be around the center. Same here. I'll create a little variable t, which will have a sine wave, so that I can use that to make the invaders move back and forth across the screen based on the frame count. And I'll call move2. And the x coordinate will be that sine wave, and the y coordinate will simply be fixed. Okay, now that we have the invader, we can introduce a family of the bad guys. And this time the members are invaders. So we'll have 4 invaders of type 1. And we'll have some invaders of type 2. And some invaders of type 3. Now we go down here. And now we also tell the bad guys to move and draw themselves. Refresh, and there they go. But as you can see, they'll be back in a minute, they're all clustered together. That's not nice. We need some lag between them. I'll introduce a variable lag, which initially will be 0. And for every invader that we instantiate, we'll increase that lag by, let's say, 25. And we'll use that lag as some kind of time displacement on the frame count. That's better. They moved off just now, but they'll be back. There they are again. Probably just should remove this by, replace this by a minus. Yeah, then it becomes more obvious. Okay. So far for the invaders. Now let's try to shoot them. Well, as you may already have guessed, there's no collision detect yet, so I can shoot whatever I like, but nothing happens. Now for the collision detect, I'm really gonna make it pixel perfect. So no bounding box collision detect. Now that sounds harder than it is, because you can use the GPU to your best advantage for that. It's actually quite simple. What you do is that when the sprites, when the images are being loaded, so before the game actually starts, first thing you do is that for every individual sprite, you'll just draw that one on the canvas. The coordinates don't really matter. I'll just put it at the top center. And once it's on the canvas, you can ask the drawing context, well, get me the image data of the rectangle where that sprite is. Once you've done that, then you'll simply clear that rectangle again. Don't forget this. Okay, now we can use that to make ourselves a collide function. It's quite similar to the draw function, so I'll copy paste that. I'll call it collide. It has the same parameters. And the first thing that we do here is to again call get image data. But this time with different coordinates. This time we'll actually use the same coordinates that we would otherwise use for draw. But of course with the same width and height that we did earlier. Oh, let's not forget to put .data behind it, otherwise it will not work. Now that we have this, all we need to do is loop through the elements of that shape. It's really an array that we get from the drawing context. And in that array, every pixel is represented by 4 elements for red, green, blue, and alpha. And we're really only interested in the alpha channel, which is at offset 3 for the first pixel. So I'll start at an index of 3 and we'll loop through the entire array. The increment will be 4 elements per pixel. And now all we need to do is just take an inclusive OR an addition of that particular element from both arrays. And if it exceeds a certain threshold, then we have a collision. And if not, then we return false to indicate there's no collision. That's all. Now that we have a collide function here, we can do the same that we did with draw. We can also propagate that to the sprite. Again, we'll copy paste because again, collide is very similar to draw, except that this time we need to do something with the return value. I'll simply put it in a new attribute named hit, so that we can then use that attribute in some kind of explode function where it will actually be checked. So if we're hit, then we'll actually explode and the sprite will be dead. And so we'll have another property named dead, and that will be 0 when you're not dead yet, when you're still alive, and it will be non-zero when you're dead. But it won't be just any non-zero value. No, it will actually be the frame number of the end of the explosion animation. We'll have an explosion animation later on. Great. So that's actually the current frame count plus the duration of that explosion. I'll have a property explosion size for that. It represents both the size and the duration of the explosion. Let's introduce some defaults for that. That will be by default 0, so we're alive, and the explosion size will be by default 15, but we can make some exceptions. For example, I would like the ship to have a slightly bigger explosion. We'll really go with a bang. And for the bullet, we'll have a really small one. And now that we introduced the notion of death, we also need to implement that everywhere. For example, when you're dead, you will not be drawn. And when you're dead, we won't do a collision detect anymore, because otherwise we'll keep exploding over and over again, even though we're already dead. Also, when you're dead, you will not move. Same goes for the bullet. If you're dead, you will not move. And once you are dead, then we should first finish the entire explosion animation before we allow you to be fired again. So for that, we'll check if the frame count is greater than the end of the explosion animation, which was stored in dead, as I already explained. Also, when you are fired again, that's kind of a respawn, right? So then the death must be lifted again. So that becomes 0. As for the invaders, same here. When you're dead, then you won't move. One more thing that we need to do is that the fact that when the player himself is dead, then he should not be allowed to fire any more bullets. So ship not dead. Okay, let's see if it works. It doesn't work yet because I still forgot something. We have all those nice methods of collide and explode, and we still don't call them yet. How are we going to do that? Well, we still start with the movement. We position every sprite. Then after that, we'll actually begin by drawing the bad guys. Then we'll have the good guys check themselves for collision with anything that's on the canvas at that moment. After that, we'll clear the canvas again. And then we'll repeat that for the good guys being drawn and the bad guys checking their collision. Then we clear the canvas again. Then we finally draw everything that's still alive. And last but not least, we'll handle the explosions. There. Now it works. And we can blow ourselves up too. Bang. Okay. Now we still need the explosion, of course. But before we do that, I'll first have a little intermezzo before I bore you all to death with this coding event. And because the background is still a bit boring, it's completely black, I want some stars in there, but not just some random pixels scattered on a black background. No, I would really like one of those awesome telescope images of colorful nebula. So I'm going to go back to the GIMP one more time. And on top of that, there's also going to be a scrolling background, which is why the height will be a lot bigger than the canvas. Otherwise, it becomes too repetitive. You know, a nebula is basically just a lot of clouds. So I'm going to use solid noise, which is called Perlin noise in other programs. Increase the resolution a bit. And those clouds, I'll go to levels to increase the contrast a bit. And I'm going to move that left slider all the way to 80. Now we have some more black between the clouds. I'll duplicate this layer. And now I'll put the stars on top of that. And stars are basically just noise. So I'm going to go to RGB noise. I'll uncheck this one to make it grayscale. And I'll move the slider all the way up to 0.7, which is a lot of stars. So we're going to remove some. I'm going to go to threshold. And I'm moving the slider all the way to the right and see what happens. Only the brightest stars are left, and because I put the stars on top of the clouds, the density of stars where the clouds have been is higher. Okay, I'm gonna blur this with some Gaussian blur, just a little bit, because those stars are really tiny, so just 1 pixel of blur. It already makes everything quite dark, so I'm gonna lift a few of those stars with sparkle. I'll leave all the defaults as they are. Okay, now we have to introduce one more layer for the colors. And for that, I'll make it half the height. That is because the filter that I'm going to use, which is also next to clouds, it's plasma. doesn't have a tileable option. And that's a shame because this background, since it's scrolling, it needs to wrap around. What I'm gonna do instead is increase the layer height to image size. Now we can duplicate this layer, flip that layer vertically, and merge those two layers together. And it's totally seamless. Okay, I'm gonna put the colors on the bottom and almost done. Now all I need to do is set the merge mode. For the top one, I'll use screen. Addition is grade 2. It makes the bright parts shine through. And for the middle one, I'll use hard light. And there we go. We can save this as stars. We're going to export it, this time not to PNG but to JPEG, because I don't need the transparency, and JPEG allows me to reduce the quality, and also because of that also the file size. We don't need a very high quality there. Okay, let's go to the styling, because there we still had the black background, and we're going to replace that by the URL stars.jpg. I'm also adding repeat Y for the scrolling. It works, but it doesn't scroll yet. We could use JavaScript to make it scroll, but it's actually much more cooler to use CSS animation. I'm going to give it a name, scrolling. And as for the time, 120 seconds. It's going to be a really slow scroll. It's going to take 2 minutes to go one full loop. And the keyframes, we have to refer to the same name again, scrolling. And it's going to go from background position Y0, which is the far top, to background position Y 2000 pixels, which is the far bottom. Save. And it's scrolling. Okay. As promised, the explosion. That's not going to be an image. It's going to be an animation that we draw ourselves using the features that we have on the canvas. So first of all, we need to set some more attributes here. Stroke style, which is the color, line cap round, and a line width, not too thin. We also need some variables here. We need a sine and a cosine here, because the particles will go, it will be some kind of particle spread, and the particles will go in all directions. So we're gonna use some rotation to make that happen. And for that we need some more or less random angle. And 1 doesn't sound very random, but it actually is, because it's not a multiple of pi, and all those angles for these functions are in radials. Okay, we'll go to the explosion function. We'll begin with a variable simply called A. I didn't have a proper name for that yet. Yeah, and what I'm going to do is I'm going to count down from the explosion size all the way down to 0. And that was the frame count where the explosion ends, and frame count is the current frame. So this is really going to count down. So as soon as it becomes negative, then the explosion is over. So I only need to draw when A is positive. Now we need the size of the explosion. I'll put that in X. And that's going to be 10 times, well, this is actually going to be an expanding explosion. So where A was counting down, this one actually has to be counting up. So I'm going to subtract A from the explosion size, do it times 10. I also have a Y coordinate because it's going to be 2-dimensional. For now, that's going to be 0. I also need a seedable random generator. I can't use math.random because that is not seedable. And the seed will be it has to be something that is consistent throughout the entire explosion, and preferably something that is different for different explosions. So that is actually ideal for that, because it's the end frame of the explosion. It remains the same for one explosion. I'll divide it by 10 because it needs to be something fractional. We'll see that later on. Now we need to set some stuff on the drawing context. First of all, I will set global alpha to because I want the particles not to instantly disappear when the explosion is over. I want to fade them out. And for that, I can use this simple expression, which means that global alpha will actually decrease from 3 down to 0. When it's 0, they are totally invisible. Actually, the value can only be between 1 and 0, so the value will actually be ignored when it's still above 1. Which means that the fading will only begin after two-thirds of the animation has passed, which is well, pretty nice. Let's not forget to set global alpha back to 1 when the explosion is over. In between here, we can actually, well, we need to call begin path to indicate that we're going to be drawing paths on the canvas, and we'll have to close that by stroke, so that every paths that we've drawn are actually filled in with some white line of a thickness of 10, as we indicated on the top of the file. Okay, now we can finally loop ourselves through each individual particle, and the number of particles will be dependent on the explosion size. I found 3 times the explosion size to be quite adequate. And for every individual particle, the third thing we'll do is to generate a random number. And for that, I came up with this function, which is, well, mathematically not very responsible, but it works pretty good for a simple animation. Now we have a random number, and now we need to draw the particle. We first need to do a move tool followed by a line tool. It will always be centered around the coordinates of the sprite. And I'll use the variable x, which is the explosion size. I will multiply that with the random numbers, that not every particle has the same speed away from the center. We do the same for the y coordinate. And as I said, after a move tool comes a line tool. Now we just put a dot with a radius of 10. I can also make it a slight line, which is actually nicer because it looks more like there's some trace behind those particles. And to make sure that not every particle goes in the same direction, we need to rotate. And that's going to be a simple matrix transformation. I need a little temporary variable for that. I'll use A because I don't need A anymore. And this is really basic matrix transformation stuff for a rotation. And now we can finally put the temporary variable back in X. If you wouldn't have used the temporary variable, then X would have been overwritten here, and it would have messed up the second formula. Let's see if this works. Okay, refresh. There we go. And blow ourselves up. Bang! That's a bigger explosion. Okay, great. Now one thing I forgot is the score counter. It still doesn't count scores. That's easy to fix, because every time a sprite gets hit, we can simply increase the score by, well, we can't use a fixed variable because it depends on which sprite is being blown up. For example, we won't award you for blowing up yourself or your bullets. So we'll have an explosion score for every individual sprite. Default value will be 0, but for the invaders, it will actually be, well, let's say it's going to be 5. Boom, I blew myself up, and I already scored something because I took one of those invaders with me along the way. Okay. Now there's still a lot of silence in here, so next up we'll create some sound. And for that I installed Sound Exchange, or SOX for short, which is normally used for manipulating audio samples, but it also has a built-in synthesizer. So this time the input stream will be none. The output stream will be the speaker, and I'm going to use the synthesizer, and I'll begin with a 1 second sine wave of 2000 Hertz. It is a bit too loud, and we'll be sorry about that once it gets mixed with other sounds in the game, because those sine waves eat up the entire amplitude, and because of that everything will be suppressed, all the other sounds as well. We'll go to a volume of 30%. And I actually want to use this as a sound where we as we fire the bullet, and it's going to be more like pew. So that's a high frequency sliding down to a low frequency. So I'm going to go down from 2000 Hertz to 400 Hertz. Now that sounds a bit meager, so I'm actually going to put some harmony in there. So I'll add another sine wave of 1 second, but this time with a frequency that's a factor 1.5 higher, which makes it sound a bit like a no, it's not good, because we need to mix them with frequency modulation. Frequency modulation really was the hottest thing in synthesizer development in the early 1980s, the golden age of video games. Okay, that sounds good. We can even distort that a bit by changing the wave shape of one of those sine waves. I'll go for an exponential wave for the second one. Great, now that sounds really retro. It's just a bit too fast. So I'll halve the time to 1.5 seconds. That's better, but still too slow. It's going to be a really fast-paced game. That's good. We're going to save this one and call it pew.mp3. I'm also going to save it as an org-vorbis file, because not every browser, for example Opera, doesn't support MP3. Now we need an explosion, of course. And so again, we'll start up the synthesizer, and this time we'll use pink noise. This is ideal for explosions. We're just going to fade it over a period of 3 seconds, which does make it a bit soft. So I'm going to increase the volume with 30 decibels, which will cause all your samples to be clipped, which will cause the sound to be distorted. But since it's it's noise anyway, so that's going to be just fine. It's actually going to be perfect. Nice. I'm going to save this one too. Call it bang.mp3. And again, also save it as an org file. Back to the editor. We'll add an audio element here. Let's not forget to add the org-vorbis. Oh. That's for pew. Also for bang. Okay. Back to the JavaScript. And we're going to add ourselves a little function here called audio. And we can pass in an ID of an audio sample, and it will return a function that we can use to play the sound. Now if the sound, oh wait, where's the sound? We need that sound. The sound is an audio element. We need to get that first. If the sound isn't already playing, then play the sound. Else, restart the sound. Okay, so we have pew, which is audio pew. And we have bang, which is audio bang. Now we have to find a place to call those things. Now for bang, that's easy. We'll just do it here. We'll only call a bang if the explosion size is big enough so that we won't call it, for example, for bullets. And we'll go to the bullet, and here's the place where the bullets get fired, and we'll call pew. Let's see if that works. Nice. Okay. Now, one more thing that I would like to improve is the attack pattern of the invaders, because that looks a bit boring. Oh, by the way, I see that I also forgot something. That we're busy with the invaders anyway. I also need to respawn them. That's pretty easy. It's simply a matter of, well, when they're off screen, which is when T is at one of the far ends, then I'll just respawn them. Yeah. Yeah, as for the attack pattern, I would really like them to come down from the top left, swoop down to the player, and then disappear at the top right again. That's a bit like a parabola, so that's pretty easy. All we have to do is just make the y coordinate a second degree polynomial, right? Yeah. Let's see if that works. Yep, that's okay. Now, basically what we have been writing here is a what they call a parametric equation. And there's a neat little program that you can use for that, and that's called GNUplot. I'm going to start that one up. And I'm going to have to set some parameters. Set parametric and size ratio. And I also need an X range. We'll use a unit range -1.5 to +1.5. And same for the Y range. And also a time range. Great. And now we can plot, well, the same formula that we had here, t and t square. And there we go. That's our attack pattern that we had right now. If we want, we can make it a bit more steep, like this. What I want is for different invaders to have a different attack pattern. So for the second invader, I would actually like some kind of loop. They still need to come swooping down. So the y coordinate is actually already pretty much okay, but for the x coordinate, I want them to come rock back and forth once before they disappear again. So they come from left, they rock back and forth, and then disappear at the right. So to do that, I can use a third degree polynomial for the x coordinate. So t times t minus 1 times t plus 1. Let's see how that works. Okay, it looks a bit weird, but if I scroll up, you'll see that it actually has that loop. And what I should do is just compress the y coordinate a bit. Subtract 0.2, and now it looks perfect. Okay, now for the third invader, I'll make it even more complex. I like the way that the x coordinate moves, but this time I'll make the y coordinate a bit more complex. It will come down, but it'll go up, down, before it goes up again and disappears. And for that we can use a fourth degree polynomial. So we'll remove this part and instead make it t minus 1 times t minus 0.5 times t plus 0.5 times t plus 1. Let's see how that looks like. Okay. We can make that a bit wider. Do it times 2. Great. Awesome. Okay, let's copy paste that. So for 3 invaders, we actually need 3 different patterns, so we'll have to use a switch statement. I'll copy paste this one to every case. Yeah. This one was 2. Okay. And let's see if we can copy paste this part here. I hope this works. There we go. And the third one, that's this one. Great. Okay, back to the browser, refresh. I think it works. Look at the red ones. They make the most complex pattern. See if they come back again. Yep, the blue ones are number 1, the green ones are number 2, and the red ones are the ones with this pattern. Okay. Now we can make that movement a bit more, well, a bit more random by actually changing the move to function a bit. Let's get this expression over here, put it down here, and I'll change the t to tx. And I'm going to make a really small amplitude, but this time with a really high frequency. And I'll do the same for y. But with a slightly different frequency. And we actually don't need the variables. Well, I'll just use them to distort the x and y here. Let's see. Look at that. Now their movement becomes a bit more erratic. Nice. Now we can do one more variation on that, because I find the number of invaders a bit too small. First of all, let's make those attack patterns instead of 4 invaders, 12 invaders. Oh wait, 16. Okay, now we have 48 invaders, right? Becomes pretty crowded. It's a bit weird how everything already starts immediately at the start of the game. What I'm gonna do is for the invaders, I'll change the default of dead to -1, so that initially they're all dead. They first need to go to the far ends of the time base, so that it takes a while for them to appear, rather than that they are instantaneously already there. That's quite a lot of invaders already. So there's now 48. Let's quadruple that number. So now we have 192 invaders. But this time we'll go to the lag and change that from 25 to 5, so that they become closer together. Now have a look what that does to the game. There they come. Vast majority here. Now this reminds me a bit of those sentinels attacking Zion in that famous movie. Captain, the dock is breached. For Zion! For Zion! Now we could go on for hours tuning this game, but if you would like more information about HTML5 development or in general and developing games in particular, then I can really recommend Mozilla Developer Network. It's from the makers of Firefox, but it doesn't mean that the information in there is Firefox specific, because all the reference guides that they have in here are based on standards, and they always have a compatibility chart which tells you exactly in what browsers and in what versions of browsers they can be used. Apart from their reference guides, they also have a really nice article series about games development, which is not just for how to create a game, but even for how to publish, distribute, promote, and even monetize your game. Now, don't be fooled. Stuff like this is not going to make you rich, but that wasn't the idea of this presentation. The idea was to have fun with creating games, with development. So thank you for your attention, and I hope you have as much fun as I did. Thank you.